recording. So I asked you guys to respond to my email that recruits the questions that we want to cover for today. Yeah, I only have 2 ladies respond to my email, but we do have a bunch of questions to cover, so that should be sufficient. Okay. Kayla has internet issue. It appears. Is Kayla here? No. Oh, she's inactive. Yeah, I took a picture of the attendance, so I should have everything, including Kayla's name in the picture. All right, so let's start it. I already started the recording. Okay, so I think Melinda asked a few questions, 5 questions. Yeah, this is the first question. Yeah, if you look at my email, I have 2 ladies respond to my email. First is Melinda, and then Kelly. So I'm going to follow the order of the time that I received the questions. All right. Yeah, we are going to go over the 5 questions asked by Melinda, and then we look at the questions from Kelly. Okay. So the first question. Let's read the question. Use a normal approximation. Yeah. Here, when we see the keywords, normal approximation, we know we are going to use a normal distribution to approximate a binomial. Well, we have to identify the binomial here, right? We need to identify the binomial here. Yeah, let's read through the question. To find the probability of the indicated number of voters. In this case, assume that 128 eligible voters aged 18 to 24 are randomly selected. So we have n equals 128. Yeah, that's the number of trials. Yeah, number of trials. N equals 128. Suppose a previous study showed that among eligible voters aged from 18 to 24, 22% of them voted. So if we see the participant is a voter as success, then the probability of success, P here, is 22%. Convert to decimal, we have a 0.22, right? 0.22. So now we are going to use the normal distribution to approximate the binomial. Yeah. So the normal distribution we are using to approximate the binomial has mu equals n times p, and sigma equals square root n times p times q. And what is q? Q is 1 minus p. Q is the probability of failure. Yeah, so it's 1 minus 0.22, which gives us 0.78. Okay, yeah. So let's see. What we are going to find is the probability that the binomial distribution variable exactly equal to 32. Right? And so here, x is a binomial distributed variable. Yeah, that's what we want. But you know, we are going to approximate. We're going to approximate using normal distribution. So from binomial to normal, we need to go through a very important process. It's called continuity correction, right? Because binomial distribution is discrete. Normal distribution is continuous. From discrete to continuous, we must do some adjustment. Yeah, how do we do the adjustment? Here, x here is normal. And the continuity correction here we're gonna apply is to give x a range, an interval is gonna be bigger than so x equals exactly 32, so 31.5 to 32.5. Yeah. So if we let x fall in this interval from 31.5 to 32.5, then we guarantee x must assume the whole number 32 and no other whole number. The only whole number x assume in this interval is exactly 32. So this is how do we do the adjustment? How do we apply the continuity correction? All right. Yeah. Remember, x is normal, right? So the mean is n times p, 128 times 0.22. Yeah. So those values are given. And sigma would be square root of npq. So we can use a TI-84 for a calculator. Yeah, everybody please get it ready. You have your calculator ready? Turn on your calculator, and what do we do? Are we gonna use which function? Yeah, normal distribution. We're looking for probability. So the function we're applying is normal CDF, normal CDF. Okay, so we are going to go to stat. No, sorry, my bad. We are going to go to second verse. Yeah, second verse. In the list of distribution, we go down and to select the normal CDF. Normal CDF. Yeah, what's the lower bound? The lower bound is gonna be 31.5. That's the left inner point of the interval. And the upper bound is gonna be 32.5. 32.5. Mu. Yeah, I'm gonna just type in 128 multiply by 0.22. And go down for sigma, I'm going to just enter second x squared, and you will see a square root with left-handed parentheses, right? I'm going to enter 128 times 0.22 times 0.78, and then close the right-handed parentheses. They close the expression with the right-handed parentheses. Yeah, by the way, your calculator might be a little bit different from mine. Yeah, so once you get familiar with the calculator, you would know how to enter the data for that entry. And then paste. What do you have, guys? What do you have? On your calculator. Exactly, I have a 0.0608131893 long decimal, right? Yeah. Then we would have to look at how do we round it. The question says round the probability to 4 decimal places. So since the fifth digit is 1, so we round it down and we have a 0.0608. Yeah. By the way, this requires you to focus and pay attention what I say. I didn't show you my calculator because we have done this many times and I show you before, right? You at this point you should be able to get it figured out by just listening to me, right? Okay, very good. So did we answer this question, everybody? This is a good question. Yeah, we use normal to approximate binomial. Yeah, how do we approximate when the probability is the binomial variable assume exactly one whole number, yeah, one value. Yeah, we're gonna make an interval, small interval, 31.5 to 32.5, and make sure x assume only one whole number. Yeah, in this interval, x only has one option, one whole number to take 32, and that would work for normal. All right. Any questions, guys? Any questions? If not, yeah, let's see. Any questions here? Okay, awesome. Yeah, thank you, Charlie. Then we're gonna keep going. The second question, Melinda asked. So let's read the question. Assume that 37% of people have sleepwalked. Wow, this percentage is higher than what I thought. 37%. Assume that in a random sample of 1537 adults, 586 have sleepwalked. So that gives us a sample proportion here. Part A, assuming that the rate of 37% is correct, find the probability that 586 or more of the 1537 adults have sleepwalked. Is that result significantly high? What does the result suggest about the rate of 37%? So I see a binomial here, and I do not see the words estimate or approximation. So this is about a binomial, okay? Yeah, I see a binomial. Number of trials. So each time you ask an adult, you ask the person in your sample, and you are applying a trial. So your N is 1537, okay? And your P assume that the rate is correct. Okay, the rate is correct. Then your P is 37%. Yeah, assume if the participant reports to you that he or she has sleepwalked, then that's a success. Yeah, she has not sleepwalked, that's a failure. Then the probability of success is going to be 37%. Yeah, read the question, assume the rate is correct. So the probability of success is 37%, 0.37. All right, so that's two important parameters for this binomial. Yeah, in this binomial, what are we looking for? We are looking for the probability that this many or more have sleepwalked. So that means we are looking for the number of success is bigger than or equal to 586. All right. Yeah, the probability that the number of success, yeah, the number of people who reports to you that they have sleepwalked equal to or more than 586. So bigger than or equal to. All right. Yeah. So how do we find that? Bigger than or equal to 586. That's a lot, right? Yeah. We want to know, we want to do is the complement. Let's see what's the complement of this event. This is an event, by the way. Yeah. Once we bring in a random variable, we are able to numeralize event. Means we are able to use this inequality to represent the event. Yeah. So what's the complement of the green? What's the complement? So all the possible values of x could assume, because we have that many trials, right? We have that many trials. All the possible values x can assume are 0, 1, 2, and so on and so on and so on. 15, 37, yeah, that many values, yeah. So what's the complement of this green event? Do you agree the complement is that? Yeah. So you have from 0 to 1, 2, and all the way to 585, and then 586, and then 587, and so on and so on, and then 1537, right? Yeah. So the event we are looking for, the green, is from 586 all the way to the maximum value, number of trials, right? And what is the complement? Is complement is going to be from 0 all the way to 585, right? Do you agree? Yeah, no more than. Yeah, why do we do this adjustment? Because the calculator has a function binomial CDF, that could help us to evaluate this probability. Okay, that's the reason. Yeah, let's see the question here. Any question here? Okay, perfect. Thank you, Charlie. Yeah, the green and the orange, they are complement. Okay. Yeah, all the possible values x could take is from 0 all the way to 1537, right? Yeah. So our event is from 586 to that, the green, and the rest is going to be the orange. So the complement is 1 minus. Why my mouse like that? Okay, so let's go to a calculator. Let's go to calculator and let's figure out what is the probability of x is less than or equal to 585. Yeah, this part is we are going to use a binomial CDF. Yeah, you might remember we also have a binomial PDF, but in this case we do not use a PDF, we use a CDF. CDF is to take care of the probability of the x no more than a value, like accumulate from the left, accumulate from 0. Okay, yeah, always from left. Yeah. Okay, so let's go to the calculator. I normally just type 1 minus. Yeah, so I would type 1 minus in the main screen, and then I go to second verse, and then when in the list of distribution, I go down to find binomial CDF, not PDF. Yeah, binomial CDF. On my calculator is letter B, binomial CDF. Okay, yeah. And the trials, number of trials is 1537. Probability of success 0.37. X here, okay, X here is our maximum, the cap of the of X in this event. So it's 585. Yeah, we're gonna type in 585. The calculator would understand, okay? The calculator now understand you are looking for the probability of X no more than 585, and then paste. And what do you have? Yeah, after use 1 to minus that, I already entered 1 minus in the calculator. So what I'm having right now is the probability of the green. Yeah, what's your answer? I have 0.1871160,333. Very precise. Yeah. So if we keep 4 decimal places, we run it down again because it's 1871160,333. So run it down is 1871. 0.1871. 1. Yeah. Miranda has yeah, if we keep 6 decimal places, 1, 2, 3, 4, 5 is 16. Yeah. So we keep 4 decimal places, it's gonna be 0.1871. All right. So that's the first part. That's the first part. Yeah. So we have to read the question very carefully. Can you go over the TID for calculator? No problem. Yeah. So I firstly in the main screen, I enter 1 minus. Okay, I enter 1 minus, and then I go second verse. You will see the list of the distributions, right? And then you go down, and then mine is the letter B. I'm not sure yours. Well, you double check is a binomial, like a BINOM CDF. There's one on top of it is PDF. We are not using that in this case. In this case, we do CDF. C here means cumulative. You're accumulating from 0 all the way to 585. And then confirm to select that. Then you would see those entries that are waiting for you to enter. Trials PX paste, right? Trials is 1537. Your probability of success is 0.37. You enter that. And X value is 585, is the cap of your inequality, is the accumulating, right? You're accumulating from 0, 1, 2, 3, all the way to up to 585. Yeah, so your X is 585. The calculator would understand it. Is a okay, so Charlie got it. Very good. And Kelly, I understand this problem is a complement, but how do we know when it's a complement or not? What is the general rule? Okay, that's a good question. The general rule is we only have two functions in the calculator, right? Yeah, for binomial. When do you use binomial PDF? Then you use that function to find the probability exactly equal to a value, exactly equal to. Yeah, when you are looking for probability of the number of success exactly equal to 10 or whatever, right? You use a PDF. And we only have two functions. The other function is a CDF. C is cumulative. And that function is to find the probability that the number of success is at the most, very important, at the most less than or equal to, you see the very thick equal sign here, less than or equal to a value. Yeah, you are accumulating from 0, 1, 2, 3, 4, all the way to X. So when you have a probability, when you're looking for probability of that, you use CDF. That's the general rule. We did not have this. Instead, we have bigger than or equal to, what is the value earlier? 586, yeah. But you cannot get it done. You cannot find the probability of that directly because only two functions. This function takes care of that. This function takes care of that. No function takes care of that. So we have to bridge, like find a path. Yeah, those two are very close, right? Yeah, so you have to find a complement because the complement is gonna be at the most. You see what I'm talking about? This is the green. This is the orange. And they are complement. Kelly, do you see why they are complement? Because they cover the whole list of values X could assume. Yes, and it's always a whole number. Yeah, always a whole number, exactly. Did I answer your question? The general rule is if you have this, you use PDF. If you have inequality symbol, yeah, okay. So let me answer your question this way. So if your probability is to find is this or this or this or this, then you're gonna figure out a way to write that probability in terms of this. Okay. So for example, suppose we are looking for X is that takes algebra. If I remember it for the exam, we will see. Yes, and it is always a whole number. Yes, if I remember it. For, oh, okay. Okay, yeah. Yeah, this part is tricky because it does use algebra. You know, statistics is based on real analysis. Real analysis is the advanced version of calculus. So in graduate school, we learn real analysis. Anyway, so it's the line of calculus. Yeah, so algebra is the foundation of calculus, right? Yeah, it does involve a lot of algebra in this case. So the general rule is if you have any of those, you have to figure out a way to write those in terms of that. Okay? So do you just subtract 1 and switch the inequality? Yeah, let me answer you this way, okay? Let's take this example. Take this question as example. So our example is to find the probability of this green, right? Yeah, that's how do we handle. Yeah, I need to write all the possible values for x. All the possible values for x is 1, 0, 1, 2, 3, 4, 5, and then 585, 586, and then so on and so on. And 13, what's the 1537, 1537. Yeah. So earlier we had this. If it's this case, that's how do we handle it. And what if we have x is strictly bigger than 586? Strictly bigger than 586 is going to start from 587, right? Start from 587. So the complement is going to be x is at the most 586. Yeah, think about this is more than 586. So the complement would be no more than. No more than is less than or equal to. So what if the inequality that represents the event is x is strictly less than 586? Then what do? And you don't do complement. You are going to adjust this strictly less than to less than or equal to. How are we going to do that? We're going to do x is less than or equal to 585. You see what I'm talking about? Yeah, this means strictly less than 586 because x only assume whole numbers. Yeah, you are right, only assume whole numbers. Then strictly less than 586 does not include 586. Then that means at the most 585. So that is the value, right? And what if the probability we're looking for is less than or equal to 586? Then we use the function directly, right? You see the 4 cases? Yeah, if it is bigger than or equal to, how do we handle it? If it is strictly bigger than, how do we handle it? If it's strictly less than, how do we handle it? If it's less than or equal to, how do we handle it? It's only those cases. I got it. I thought you put 585 on the first half of the first question, so I got confused. Oh, I put 585 in the first half of the first question. First half of the first question. First, I don't get it. I'm sorry. I didn't write anything wrong. Let me double check.
Yeah,
Bigger than or
I know.
equal to.
It wasn't your fault. I just misread it. I thought you put 585, like x is greater than or equal to 585. And then on the second half it was x is less than or equal to 585. That's what I thought you put, but it's 586.
Yeah.
So I just misread it.
Okay. Yeah. So the important thing is you want to make sure if we need to use complement, you want to make sure this green and this orange cover the whole thing. Yeah, cover the 0, 1, 2, 3 all the way to 1537. Every single whole number. Nobody is left out. That's the key. All right. Yeah, it's very pretty interesting to play with that because it's discrete. Yeah, we have other discrete distribution, but binomial is the most basic and common one. Yeah, you just need to play with this. And continuous would be a totally different story. Yeah. All right, did I answer the question? So that is part A. Let's see part B. Is that result significantly high? The probability is 0.18, so almost 19%. 19% is not less than 5%. If the probability is less than 5%, we say is significant. But 18% is not significant. Yeah, it's not rare, means not rare. No, because the probability is greater than 5%, right? Yeah, right here, 5%. And part C, what does the result suggest about the rate of 37%? Because rare event does not occur in one trial, then since a rare event does not occur, we have no reason to doubt the assumption that the rate is 37%. So since the result is not significantly high, is not strong evidence against the assumed rate. Okay, so that actually is from the future chapter, hypothesis testing. Hypothesis testing, after we learn that chapter and we go back here, you would completely understand what is significantly high. Why would we say, why would we accept 37% if it's not significantly high? Basically, the idea is we reasonably assume rare event will not occur in one trial. It's like I go out to buy a lottery. You want to just win millions of dollars in one trial. We assume that's not going to happen, right? That's why many people they don't go buy the lottery. Yeah. So also we assume if today I go out to drive to my work, I will not have accident, right? So because it's a rare event, yeah, we assume a rare event will not happen in one trial. So if you collect your sample, you did the trial, and your result end up with a rare event happened, yeah, that is something significant statistically. So that means that something went wrong, right? Yeah. What went wrong? If your process is correct, nothing wrong with the process, that means your assumption has something wrong with your assumption. So you have some evidence to challenge your assumption. So here our assumption is 37%. And you do your own research and you do not get a significantly high result, like the rare event does not happen. 18%, 19% is not rare. Yeah, could happen by chance. So there's no reason you challenge the assumption that a 37% rate. So that's the rationality, the reasoning behind many multiple choice question in MATLAB math, right? Yeah, you will see something in the test for sure. Yeah, that's the reasoning behind it. In the future chapter, we're going to learn hypothesis testing. You will understand that better. Okay, let's see the third question. Let's read it. There is a 0.9985 probability that a randomly selected 27-year-old male lives through the year. Oh, okay. A life insurance company charges $189 for ensuring that the male will live through the year. Very likely, almost, right? Is very young. If the male does not survive the year, the policy pays out $110,000, okay, as a death benefit. Complete part A through part C. This is going to be a probability distribution problem, okay? Part A. From the perspective of the 27-year-old male, okay, now we are the guy, okay, we are a 27-year-old guy. We're considering, am I going to buy the insurance or not, right? Yeah, am I going to buy the insurance or not? So, two cases. Either I die No, either I survive. Yeah. So if I survive the year, I lost. No, hold on. I cannot say that. If I survive the year, money-wise, yeah, money-wise, I do lose $189. The profit is a negative $189, right? Of course, it's good that you survive. So that's the profit, okay, money-wise, yeah. But in the case that the person does not survive, okay, if the person does not survive, of course, he has nothing, but his family gonna have 110,000, right? Yeah, gonna have that income. I'm sorry, describe that income, like a money getting in, yeah, money coming in, and then minus the money come out. So 110,000 minus 189, you're gonna have this value, right? So that's the profit. Yeah, just let me to describe as a profit in the second case if the person died. All right. And that part is to help us to build the probability distribution here actually. Okay. Probability distribution table is a 2-column table. And I'm going to use X to be the profit money-wise, okay? Yeah. And then the second column is a probability. We only have 2 cases, so we only need 3 rows. Yeah, those are 2 rows. So in the case that the person survive, the profit is a negative 189, and the probability of surviving is given is 0.9985. Yeah, so that's the case. That's the money gain or lose, and its corresponding probability. And the second case, the guy did not survive. Yeah, and the money-wise, the money is $109,811, and that probability. Anyone can help me with the probability? Yeah, we only have 2 cases, right? Either survive or not survive. So if the survive probability is 0.9985, the not survival probability would be 1 minus, yeah, 1 minus 0.9985, and that gives me 0.0015. 0.0015. So 0.15% or 1.5 per thousand, or yeah, or 15 per 10,000. So 15 people every 10,000. 15 people every 10,000. That's the people didn't survive at that age. Okay, awesome. Thank you, Dustin. All right, we are ready to find the expected value. Yeah, part B is to find the expected value, right? Yeah, or mean or average. I'm going to use a different color to extend the table because I want to just use the table to find the product. Okay, yeah, negative 189 times the probability 0.99, too small, 85. Yeah, take the product, and this one is positive 109A11 times 0.0015, right? 0015. Okay, so get a product done, and then sorry, add them up. Okay, yeah. On your calculator, you do I do parentheses. I do the structure very clearly. Negative 189 times 0.9985, close the parentheses, and then plus, start a parentheses, 109811 times 0.0015, close the parentheses, and I have, oh, hold on, something, I probably typed something wrong. Let me do it again. Negative. Oh, negative sign. You see, sometimes I made a mistake. Negative sign is not minus sign. Negative sign 189 times, yeah, guys, if you need to enter negative, please don't use the minus sign. Yeah, sometimes we forgot, but make sure we use the correct sign. Negative 189 times 0.9985, and then plus positive 109811 times 0.0015. You see, this time works. Yeah, negative 24 exactly. Negative 24 exactly. So we take the perspective of the guy. That means if I buy the insurance, I'm expecting to lose $24. Yeah. Well, considering the advantage and the disadvantage, everything considered in it. Yeah. So I'm expecting, or in the long run, or not in the long run, for many 27-year-old male, yeah, averagely speaking, they are expecting a typical male who bought the insurance are expecting to lose $24 for that year. Okay. Can the insurance company expect to make a profit? Yes, of course. That means if the insurance sells many insurance, the policy, many people buy the insurance, the 27-year-old, then everybody, the company expects to get $24 profit from every single one. While if you $24 from one person, and if you have a very large base, then that's a very considerable profit for the company. All right, so that's about probability distribution. I mentioned last time, but I'm going to emphasize again. In the test, if the table is given, even you know it's binomial, do not use the formula. Okay, yeah, you use the method. Yeah, you use the expected value to find the NP. Do not use the formula. Of course, this one is not binomial. It's not binomial. All right. Any question about that problem? Any question about that problem? Okay. Thank you. Okay. So let's see the next question. Yeah. Thank you, guys. Yeah. This one should be straightforward. Yeah. And when I see this kind of problem, okay, calculator, get it done very fast. Find and indicate the IQ score. So we are looking for X score. We are looking for value. Yeah. So here is a good thing to summarize the functions in the calculator about normal distribution. We have two functions to use. One is a normal CDF. The other is the inverse normal. Okay. We only use those two. Yeah. And when we need to find a probability, percentage, frequency, area, are we allowed to use the calculator, or do we need to use the table? You are allowed to use a calculator, Kelly. You are encouraged to use TI-DATA for calculator. All right. Yeah, you are encouraged to use. I don't use table. When I learned myself at school a long time ago, we only have a table available. You know, the calculator is expensive. Change it to Chinese dollar, Chinese yuan, that's gonna be a lot of money. We don't use that at all. We manually use a pen, and we'll use table. So, but we have those available here, and that could make your job a lot easier. Why not, right? Yeah. You can borrow one. I'm not saying you have to pay. So if we are looking for probability, percentage, area, we use normal CDF. But if we are looking for the value or percentile, by the way, is a value, okay? The value separate top how many percent, bottom how many percent. Yeah. If that, we are using inverse normal. Question: We are looking for x here. Okay, we are looking for x here. So are we using normal CDF or are we using inverse normal? Yeah, look at the picture. I don't even have to read it. Yeah, in this case, are we using normal CDF or inverse normal? Perfect. Inverse normal. Perfect. Very good. Yeah. Inverse normal. Okay. Calculator. Very important thing. Okay, guys. If this blue or green or blue, that's green, right? Okay. So if the green area is 0.6, what is the area of this blank? Huh? 0.4, right? Because the whole area under the curve, awesome, awesome, guys. Because the whole area under the curve must be 1. So if that part is 0.6, the other part is going to be 0.4. And you know what? When we use it inverse normal, we are going to use 0.4, not 0.6. Yeah, actually, it's similar with the binomial CDF earlier. Is accumulating. It's kind of like a convention that we have to follow. Yeah, we are accumulating from net infinity all the way to x. Yes, from the left. Yeah, on the left tail. Yeah. Okay, so turn on the calculator. We go to second verse and go down to select inverse normal. You will not see the whole word INVERS, normal, but you will see those key letters. That would be enough for us to identify INV norm. Yeah. Okay, the area, please do not enter 0.6. Instead, you're going to enter 0.4, okay? And your mu, what's the mu? Oh, it's here. Mean is 100, so enter 100. Sigma, 15, so enter 15. Paste. There we go. Tell me, please, what's the value you are looking at on your calculator? Round to 1 decimal place. I have 96.199799348. That's my calculator. Yeah, we rounded up to 1 decimal place. 96.2. You guys great. All right. Yeah, I would say that's a very straightforward, but it's a good question for us to review here. Yeah, for normal functions in the calculator, either CDF or inverse normal. Yeah, when do we use the CDF function? When do we use the inverse function? Very good. Next, a boat capsized and sunk in a lake based on an assumption of a mean weight of 147 pounds. The boat was rated to carry 70 passengers, so the load limit was 10,290 pounds. After the boat sunk, the assumed mean weight for similar boats was changed from 147 to 175. I don't understand that. After the boat sank, and they changed the average assumption bigger. Complete parts A to B, A through B. Okay, assume that a similar boat is loaded with 70 passengers, and assume that the weight of people are normally distributed. Okay, here, let me note the make some notes. Assume we have a normal distribution here with mu equals 179.6 and a standard deviation equals 39.1. Find the probability that the boat is overloaded. Then how do we describe or measure the boat is overloaded? Here is that. If the 70 passengers have a mean weight, okay, mean weight. So we are looking for the probability of X bar. Yeah, how do we know that? Because it says so. Yeah, mean weight greater than 147. All right, so let's see. Central limit theorem, right? It doesn't matter the sample size. Yeah, sample size certainly is also big. An important thing is the population is normally distributed. So X bar follow mu normal distribution with mu and sigma over rho n. Remember that? Yeah, the distribution of mean, distribution of sample means. So we are going to use the normal CDF function because we are looking for probability, right? Yeah, X bar is normally distributed. Yeah, X bar is normally distributed. And the lower bound, because it's bigger than 147. 147 is the lower bound, 147. And the upper bound is past infinity. Remember that? And the mu is 179.6 and sigma is 147 divided by rule 70. Okay, yeah, we're gonna enter those in the calculator. Yeah, let's see what we have. Go to second verse, go down normal CDF, lower bound 147, upper bound double E 99. Yeah, at this point you should know how we enter infinity, right? Mu is 179.6. Sigma is 149 divided by square root of n. N is 70. Close the parentheses and then paste. What do you have? I do not have 1. So, okay, round to 4 decimal places. I have a 0.9664. Let me double check. Second verse, normal CDF is bigger than. Mean is bigger than 147. It is 179.6. Oh, I entered wrong answer. I entered wrong number. I'm sorry. Sigma, I entered 100. Sometimes, yeah, that's the thing. I thought that's a 9. That's a 7. My bad. 147. Yeah, 147. Hold on. Oh, my bad. Sigma is 339. Sorry, 391. Yeah, this is sigma. 391 divided by 70. So rule 70. So let me fix that. 391. 300. Yeah, it's always good to double check your answer, right? Yeah, we are human beings. Sometimes we'll enter wrong number, even if this is there, 391. Divided by rule 70. Close and paste. Now I have bigger than 147. Sigma 391.
I think it's 39.1, not 391.
Oh my gosh. Oops. Yeah. You are right. I confused myself because I did not write it very properly. I'm sorry. 39.1. Okay. Fix that. 39.1 divided by rule 70. So now I have a value 1. Do you guys have a 1 as well? Yeah. Yeah. So it's always to double check because we are human being, right? We are not computer. Sometimes the computer have a glitch, you know. Once in a while that might happen. Yeah. So we just need a clear mind. And very important is we should just write it down properly, right? Yeah. We should write down properly. Okay, so part B, the boat was later rated to carry only 15 passengers. And the local limit was changed to 2,625 pounds. Find the probability that the boat is overloaded because the mean is greater than 175. Yeah, again, we are looking for mean. Yeah, the probability of mean is greater than 175. Okay, so that the total is greater than 2,625. Okay, so in this case, similar with earlier, but the only difference is gonna be, yeah, the lower. This time, let me write it nicely. Lower is 175. Upper E99. Mu stays the same. Stays the same. 179.6. And sigma this time is 39.1 divided by, not root 70, is root 15. Yeah, let me double check. Okay, so the, yeah, assume, yeah, that's the assumption for the whole question. It's also so tiny. Everything's so tiny. 179.6, and then standard deviation is 39.1. Yeah, 39.1 over root 15. Yeah, because this time the people in the boat is only 15, right? So that's the sample size. Okay, go to second verse, normal CDF. Lower bound 175. Upper bound E99. Mu is that, and then sigma is 39.1 divided by square root 15. And I have 0.675677372. And we keep four decimal places, 0.6757 rounded up. Do you guys have the same thing, guys? Yeah, this is to find the probability of sample means. Yeah, central limit theorem. Okay, all right, very good. Part C. Do the new readings appear to be safe? The probability that boat overloaded is 60, almost we rounded it up 68%. That's a large probability. I don't think it's safe. It's about people's death, life and death, right? Because there's a high probability. Yes, you know, high or low is depends on the context. In this case, it's about people's safety, life. So that's a high percentage for sure. Because there's a high percentage, high chance of overloading, the new reading do not appear to be safe when the boat is loaded with 15 passengers. Even it's a lot better than 70, right? 70 is like definitely will sink. And this is better, but still not safe. Okay, so that's the questions from Melinda. Yeah, and then Kelly sent me a PowerPoint. No problem. Thank you. Thank you for your participation. Yeah. At the beginning, I don't see, oh, only 2 people respond me. Am I gonna have 2 questions? And I look at it, it's not only 2 questions. You asked several. Okay, so this PowerPoint is from Kelly. Let me see if I can write on it. Oh, nice. I can write it on it. Perfect. This is the first question. Let me make it bigger. How do I make it bigger? Let's see. If we do full screen, yeah. A survey found that women's heights are normally distributed with mean that and standard deviation that. The survey also found that men's heights are normally distributed with mean that and standard deviation that. Most of the live characters employed at an amusement park have a height requirements of a minimum 56 inch and a maximum 64 inch. Okay, complete parts A and B below. Find the percentage of men meeting the height requirement. What does the result suggest about the gender? Okay, let's do the first part first. So we are looking for percentage, right? That means we are looking for a probability of randomly select a person and the person's height is between minimum 56 to meet the requirement minimum 56, maximum is 64 for men. So we don't consider women in this case. Yeah, and the man is normally distributed with mu equals, where is the mean equals 68.1, sigma equals 3.7. Okay, 3.7. Yeah, sigma is not going to be too big like that. All right, okay, so use normal CDF because we're looking for percentage, right? Yeah, our lower bound 56, our upper bound 64, our mu 68.1, our sigma 3.7. Yeah, that's gonna be a pretty straightforward thing to do. So let's go to second verse. Normal CDF, lower bound 56, upper bound 64, mu 68.1, sigma 3.7, paste. And what do you have? I have a 0.133370324. Let's see, do you have the same thing with me? Want to keep the link? Oh, my writing disappeared. It's gonna be less than 1. Oh, percent. Okay, yeah. So the probability, the percent is gonna be 0.13337. Yeah, let's see how do we round it. How are we supposed to round it? Round to two decimal. Oh, it's a percentage, guys. It is even percentage. You still need to round the decimal to 4 decimal places. Okay, the decimal is 0.13337. If you convert to percent, yeah, we run it down to 0. It's pretty reasonable. And you to percent, you move the decimal point to the right twice, and you have 13.337%. Yeah, but you need to keep 2 decimal places, right, in a cell. So you're gonna round this to 13.34. 2 decimal places. Yeah, 13.34. I think most of you misunderstood the rounding here because you gave me 0.13. 0.13 is not enough. Not enough. Basically, you still need to round a 4. Keep 4 decimal places because after you move to the right twice, you still have 2 decimal places. Do you see what I'm talking about? So in the answer already have a percent sign here. In the cell, you only need to enter 13.34. All right, guys. You see what I'm talking about? Yeah, even this question I would say is straightforward, but the rounding might get someone, you know. Yes or no, guys? Do you see what I'm talking about here? Yeah. So 0 from 13 is not enough. Is not enough. You are rounding. You are giving a percent point with the percent sign follow that number. So you need to keep 4 decimal places.
Now we see that now. I didn't see the percent sign whenever I was doing the calculations.
Awesome.
So yeah.
Perfect. Yeah. It's always good to pay attention to that, right? Otherwise, with the whole thing, we get it right and then eventually get it wrong because the rounding, that cannot exchange. Since most men, and what is that? The high requirement. So I would say most of men does not meet the high requirement. It is likely that most of the characters going to be women. That makes sense, right? It's only a small percentage of men can meet the requirement. So because women generally is shorter, so that'd be better. Okay, let's do the part B. If the high requirement are changed to exclude, okay, exclude the tallest 50%. That's a better drawing. At least we need to do symmetric. Okay, those 50%. Yeah, those 50% gone. We don't need those 50%. Exclude them. And also the shortest is 5%. Those 5%. We don't need them. Too short. Those too tall. Yeah, we want only the white part, right? The blank part. Yeah. And then what's the new standard? Yeah. The new high requirement has a minimum of what and a maximum of what. So this is going to be the minimum. This is going to be the maximum. All right. Isn't the maximum easy to find, guys? It's in the middle. It's right in the middle. Yeah, this one happened to be 50% exclude. Anybody can tell me what's the maximum? This value. Isn't the value center? The center. The man, okay, let me organize the information here. The man has the mean 68.1. Yeah, man meal is 68.1. Sigma is 3.7. So do you agree the maximum is 68.1 inches? Awesome, exactly. The mean, exactly. The center, awesome. Very good. And that leaves us to figure out the minimum, right? Yeah. Are we using normal CDF or are we using inverse normal? We are using inverse normal, right? To find the value, to find the x value. Okay, in the inverse value, inverse normal, let's go to second verse. Inverse normal. Area. Yeah, what's the area here? The area has to be the area of the region to the left of the value we are looking for. So 5%, 0.05. 5% is 0.05. And the mu is 68.1. Sigma is 3.7. Paste. I have 62.01. 404. Okay, let me write it down. The minimum is 62.01, 404, 158. Okay, now we need to figure out the rounding. Okay, minimum. So we're gonna exclude the 5%. We keep 1 decimal place. So keep 1 decimal place. Oh, that one is just 62. We round it down anyway. Yep. 62.0. Do we do the 0? 62.0. Yes, that's correct. All right, do you agree, guys? Is inverse normal? The minimum requirement is that. Then we can exclude the shortest 5% man. Any response? That was the part I was struggling with. Okay, no problem. Thank you. Yeah. And that's that. First page. Second page. Yeah, let's see this question. A survey found that women's height. Oh, different question, right? And then men's height. Okay. Consider an exclusive. Oh, okay, it's different question. Consider an executive jet that C6 with a doorway height. Okay, this is the height. Complete part A through part C. A, what percentage? So we know we're gonna do CDF, yeah, normal CDF. Of adult men can fit through the door without bending. Okay, so basically, yeah, so we are looking for the percentage of adult men fit through the door without bending. Actually means we are looking for the probability that a randomly selected man has the height less than 55.9. And you might wonder, less than or less than or equal to doesn't matter because it's continuous, right? Yeah. So we do strict less than is no problem. 55.9 is the height of the door. So we are looking for that probability. Now X follow normal with mu. What's the mu? 68.5. Sigma 3.7. Okay. All right. So that's a simple normal CDF application. So go to second verse, normal CDF, lower bound, negative infinity. So negative double E 99. Upper bound 55.9. Mu is 68.5. Sigma is 3.7. Paste. I have, okay, so I need to probably mention this. So the probability I got is 3.303806562 e to the power -4. Yeah. So I want to explain e to the power -4 actually is how the calculator record the number in the scientific notation. So this means the decimal multiplied by 10 to the power -4. So it means we actually need to move the decimal point to the left 4 times. 1, 2, 3, 4. So the answer is supposed to be 0.0000, 33 something, right? Yeah. So decimal actually is 0.000330 something. And to percent, convert to percent, we would have 0.033038, that many percent. And once you have the percent, and then you round to 2 decimal places needed. So you look at this digit, is it less than 5? So round it down. So 0.03%. Am I clear about that, guys? Yeah, I get a habit. I want to keep as many as possible digits to make it as precise as possible. Okay, very good. Perfect. And the next part B. Does the door design with a height of 55.9 inch appear to be adequate? Let's think about it. Oh, hold on. Who can fit without bending? Wow, that's almost all the men have to bend, right? No, it's not adequate. Why didn't the engineers design a larger door? We can guess. If the door design is inadequate because most of the men have to bend. The reason it doesn't design a larger door, probably because it's in the plane. They don't really go through the door very often, right? It says because the jet is relatively small and only six people, a much higher door would require major change in the design and the cost of the jet, making a larger height not practical. Yeah, I agree. Because you don't really get up and then pass the door that often, right? Is most of the time you sit there. Percy, what doorway height would allow 40% of men to fit without bending? Okay, 40%. Allow 40% not bending. So allow 40% not bending. So we are looking for this value. Right? It fits the lowest, the shortest 40% people. So this is going to be an inverse normal problem. All right? Yeah, so get a calculator ready. Go to second verse. Inverse normal. Area. Yeah, again, the area has to be the area of the region to the left of the value we are looking for. So 40%, 0.4. Mu. 68.5, right? Still man? Yeah, 68.5. 68.5. Sigma 3.7. Paste. I got a 67.56261573. Round to 1 decimal place as needed. 67.6. Do we have the same thing, guys? Yeah. Okay. Very good. So we did not finish everything, and we only have 1 minute left. If you need help, you are welcome to make an appointment with me Tuesday morning and Thursday morning around 10 o'clock through Zoom. Okay. Yeah, we would have to stop here. Yeah, my calculator makes me pick left, center, or right. How do I know without drawing graph? Okay, Charlene, what calculator you are using? What type? Casino? No, casino, I'm sorry. Casio? Okay, then you are not using the right, you're not using the right Python? Oh, really? Okay, no problem. Thank you, Kylie. Python, you are using Python? Then you use left tail. Really, you are using Python? It's not allowed for the test, though. TID4 plus CE, then what do you enter Python? If you have that, then choose the left tail. Left tail. It says Python on calc. Okay. I'm guessing, okay, I'm just guessing. Maybe are you using the correct function? Second verse, inverse normal. Yes, okay. Mine doesn't have that. Yeah, mine doesn't have that. How about you take a screenshot of your calculator or take a picture, and I have to look at it to answer your question. How about that? I would answer your question tomorrow because it's pretty late today. Does that work? Let me take a picture of the attendance before you all go. Okay, no problem. Yeah, feel free to email me if you have any other questions. I'll say good luck for the test. All right. Have a good night, everybody. Bye bye.